Hello everyone, myself D.S. Vinay Kumar. Presently I am working as a guest faculty in Government Polytechnic Raichur. I am handling the subject Surveying 2 for 3rd sem. Today I am going to teach the first unit, Theodolite Surveying. So the instrument you are seeing in the picture is known as Theodolite. It is similar to dumpy level, but here the telescope is fixed to the standard A-frame, not to the horizontal plate. Now, this instrument, Theodolite, is used to measure horizontal angles, vertical angles, and also it is used to take staff readings by keeping the telescope truly horizontal. Here it means keeping the telescope truly horizontal means keeping the vertical circle to 0 degrees. So by keeping the vertical circle to 0 degrees, you can take the staff readings and you can determine reduced levels of the ground, just as the dumpy level. In the previous semester, you have used prismatic compass to measure the horizontal angle. But here, you are going to use Theodolite to measure the horizontal angles and also to measure vertical angles. By using prismatic compass, you can only measure horizontal angles. There you can't measure vertical angles. And the other difference between a prismatic compass and a Theodolite is least count. The least count of a prismatic compass is 30 minutes. But here, in most of the general instruments, Theodolite instruments, the least count will be 20 seconds. In some special Theodolites, the least count may go up to 0.1 seconds. So, the Theodolite is far more accurate than prismatic compass. Now, the difference between the Theodolite and dumpy level. Dumpy level is used only to measure staff readings, but here the Theodolite can be used to measure staff readings and to measure horizontal and vertical angles. So, the main difference between a dumpy level and a Theodolite is the telescope. The telescope of a Theodolite can be reversed in 180 degrees in the vertical plane through horizontal axis. Here in this animated image, you can see the telescope of the Theodolite is moving or it is getting reversed. But in the dumpy level, you cannot be able to reverse or move the telescope in vertical plane. You can only rotate the telescope, you can only rotate the telescope in the horizontal plane through vertical axis, but you cannot rotate the telescope in the vertical plane through horizontal axis in dumpy levels. So, the next topic is types of Theodolite. So primarily the Theodolite is differentiated in two types. The first one is non-transit Theodolite and the second one is transit Theodolite. Non-transit Theodolites are the Theodolites in that the telescope cannot be revolved or plunged in the vertical plane. The non-transit Theodolites are just like dumpy levels. There you cannot reverse the telescope. The next one is transit Theodolite. Here in the transit Theodolite, you can rotate the telescope in 180 degrees in the vertical plane, just like this instrument which is shown in the image. This is a transit Theodolite. So, based on the facilities provided to the instruments, the Theodolites are further classified as vernier transit theodolite, optical glass arc theodolite, electronic theodolite. Now let's move to the difference between a dumpy level and a transit theodolite. Here in the transit theodolite we can measure horizontal and vertical angles, and also by using the trigonometrical relations we can also determine horizontal and vertical distances indirectly, and also by keeping the vertical circle to 0 degrees we can measure staff readings just like dumpy level. But here in the dumpy level we can only take staff readings with respect to the line of collimation, and we can only able to determine the reduced levels here. We cannot be able to measure horizontal or vertical angles. Now the next difference is the permanent adjustment of theodolite will be dependent upon 5 fundamental lines. So in the next slides we are going to learn about these 5 fundamental lines and the relations between them. And the difference between theodolite and dumpy level is the permanent adjustment of dumpy level is based on 3 fundamental lines. So the next one is transit theodolite can be called as an universal instrument for its various uses. We can use transit theodolite to measure angles, either it may be vertical or horizontal. We can measure distances, horizontal and vertical with trigonometrical relations, and we can also use it as a dumpy level. But the dumpy level cannot be used as a theodolite to measure the horizontal or vertical angles. We can only take staff readings with the reference to the horizontal line of sight or line of collimation. Now look at this cross-sectional picture of a theodolite. Here the components are labeled. You can see vertical circle which is passing through exact center of the instrument perpendicular to the ground, and the other one is horizontal axis which is perpendicular to the vertical axis. Here you can see this portion, this is called as vertical circle, and beside that you can see an adjustable mirror and an altitude bubble, and you can see here plate bubble. So in the dumpy level you can only able to see one bubble tube which is placed on the horizontal plate, but here in the theodolite you can be able to see 2 bubble tubes. One is placed above the horizontal plate and the other one is placed just beside the vertical circle above the A-frame. Now the other is in the same manner, just similar to the dumpy level. Theodolite also have trivet, tri-brach and the 3 foot screws which is called as leveling head. Let's study about the component parts in detail. The first one is leveling head. Here you can see the animated image which is showing leveling head. The first plate which is above is known as tri-brach. The very below plate is known as trivet, and these 3 screws are known as foot screws. You have already familiar with the tri-brach, trivet and foot screws while reading about the dumpy level. Now in the same manner, this leveling head portion is attached to the spindle of the theodolite. So this is the lowermost part of the theodolite instrument. So it has a lower plate and an upper plate. The lower plate is trivet and the upper plate is tri-brach, and between them there will be 3 foot screws. So the next one is lower plate. So above the leveling head there will be 2 horizontal plates. These 2 plates are very important for measuring the horizontal angles. Here the lower plate is also called as main plate and scale plate. This main plate is graduated in circular manner. The complete plate is graduated in degrees and minutes and it is graduated from 0 degrees to 360 degrees, and the difference between each division is 20 minutes. So in the main scale you can be able to see degrees and minutes only. There will be no seconds division in the main plate, and here each fifth degree is numbered. Here you can see the lower part, this one is main scale. Here for every 5 degrees it is numbered. So if it is 10 degrees, 11 degree, 12 degree, 13 degree, 14 degree and 15 degree. The 11, 12, 13 and 14 degrees are not numbered. Directly after 10 it is numbered as 15. So for every 5 degrees it is numbered. So the below part is known as main scale. So here you can be able to see main scale. So the diameter of the main scale varies from 100 to 150 mm. So the lower plate can be locked. So the lower plate can be rotated in 360 degrees. So to lock the movement of the lower plate, we can use a screw which is known as lower clamp screw, and for the finer movement of the lower plate we can use a lower tangent screw. So the lower plate is fixed to the outer hollow spindle. There will be 2 spindles, one is outer spindle and the other one is inner spindle. The inner spindle will be solid in nature and the outer spindle will be hollow in nature. This lower plate will be attached to the outer hollow spindle. Here you can see the lower clamp screw which is used to lock the movement of the lower plate, and this is the lower tangent screw which is used for the finer movement of the lower plate. Lower plate is nothing but main scale or scale plate. So the next one is upper plate. Here you can see this circular portion, this is called as upper plate. This will be attached to the inner spindle. Just it will be placed above the lower plate. Now this upper plate is also called as vernier plate because the upper plate will be attached to the vernier scale. Here in this image you can see vernier scale above. This above portion is known as vernier scale. Here you can see the vernier scale is graduated in minutes and seconds. These are minutes, the index is nothing but 0 minutes, the next one is 5 minutes, 10 minutes, 15 minutes and 20 minutes. The vernier scale is graduated from 0 minutes to 20 minutes. It is only graduated from 0 minutes to 20 minutes, and this scale will be having seconds graduations. So the least count of vernier scale is 20 seconds. So the each 1 degree minute is divided in 3 portions, and each portion is 20 seconds. So for every 60 seconds then it will be a minute. Now for locking the movement of the upper plate, we are going to use upper clamp screw, which is visible here, and for the final movement of the upper plate we are going to use this slow motion screw, or this also called as upper tangent screw. For the final movement, the screw which are going to use is called as upper tangent screw. Here you can see vernier. Here in the animated image you can see a portion which is glazed. This glazed portion is used to read the graduations inside the upper plate, which means you can be able to read the horizontal angles with the help of this magnifying glass. So inside this magnifying glass you can be able to see the vernier scale and main scale. Using these vernier and main scale you are going to read the horizontal angle. So now if we are going to tighten the clamp screw of the upper plate, and if the lower plate is loosened, then both the upper plate and lower plate will be going to rotate together, and the readings inside the vernier will not be changed. So the next part is shifting head. Shifting head is provided in between the trivet. Here you can, in the trivet, the shifting head is used to move the instrument a slight. So for centering the instrument you can be able to move the instrument slightly with the help of shifting head. So the next one is plate levels. So you all are familiar with bubble tube, which you have seen in the dumpy level. In the same manner, that theodolite also have a bubble tube which is placed just above the upper plate. So this bubble tube is known as plate level, and here in theodolite there will be other bubble tube which is placed just above the telescope or above the A-frame, which is known as altitude level. So for this reason the bubble tube which is placed above the upper plate is known as plate level. So while you are going to measure horizontal angles, you should refer to the bubble tube which is placed just above the upper plate. So the next one is altitude bubble. Here you can see a bubble tube which is placed just above the A-frame to the vertical circle. So this bubble tube is used when you are going to measure vertical angles using the vertical vernier scale. So with the help of altitude bubble you can be able to measure vertical angles. So the next one is standard frame. Here you can see a A-shaped frame which is going to support the telescope and vertical circle. Here this A frame is known as standard frame. This indicates the letter A, so this is also called as A frame, and this is also called as standard frame. So this standard frame is attached to the upper plate, and this is going to support telescope and vertical circle. The horizontal axis is going to pass through the A frame. So the next one is vernier frame. So the vernier frame is also called as T frame or index frame, and it has a vertical leg here in this image you can be able to see the number 10, which is vernier frame. So here for the measurement of angles, vertical angles, you are going to need an index frame. This index frame is going to help you read vertical angles. So the vernier C and D are engraved to the vertical leg, which I have shown in the figure. So you will be able to read the vertical angles with the help of vernier C and D, which are attached or which are engraved on the vertical leg or clipping arm. So the next one is telescope. So the telescope is mounted on horizontal spindle, and this is called as horizontal axis or Trunnion axis. Between the two A-frames, the telescope will be fitted, and the telescope is pivoted, and the telescope can be revolved 180 degrees in the vertical plane through the horizontal axis, which is passing through the standard frame, and which is exactly perpendicular to the vertical axis. And here the telescope of the theodolite may be internal focusing type or external focusing type. The internal focusing types are the lens. If you are going to zoom or if you are going to focus, the diaphragm inside the telescope is going to move, and you cannot be able to see the movement of object glass or eyepiece. But here in the external focusing type, when you are going to rotate or when you are going to focus, then the object glass will be moved outside and inside, and it is telescopic type, just like the radio antenna. So the next one is vertical circle. The important part is vertical circle, which is attached to the A-frame just beside the telescope, and this vertical circle will be having two magnifying glasses which will help you to read vertical angles. Here inside the vertical circle there will be a graduated arc which is engraved in the graduations. So the graduations will be in 4 quadrants. So each quadrant is divided from 0 degrees to 90 degrees. So you can be able to read the vertical angles using these graduations which are engraved on the arc. So the least count of this vertical circle is 20 seconds. Just like the horizontal circle, these graduations are also engraved. So here you can see the magnifying glasses, and through these magnifying glasses you can be able to read the vertical angles. The next part is screws. So you all are familiar with foot screws while using the dumpy level, and also focusing screw. Now here the extra set of screws are called as clamp screws and tangent screws, which are fitted to the theodolite. Now leveling screws is nothing but foot screws which are going to be used to level the instrument with reference to the altitude bubble or with reference to the plate level for the horizontal measurements. So the next set of screws are clamp screws. So I think I have already shown you clamp screws, lower clamp screw and upper clamp screw, which are going to use to lock the upper plate. You are going to use upper plate clamp screw. To lock the lower plate, you are going to use the lower plate clamp screw. And to lock the movement of the vertical circle or to lock the movement of the telescope in the vertical plane, you can use vertical circle clamp screw. And also for the finer movement you can use the vertical circle tangent screw for the finer movement of the telescope to set an accurate angle. And also in the horizontal area you can use upper plate tangent screw and lower plate tangent screw for the finer movement, for the finer horizontal movement of the telescope. So the next one is spindles. So there are two spindles attached to each other. The one is inner spindle and the other one is outer spindle. The inner spindle is completely solid and it is encased inside the outer spindle, which is hollow in nature. So these two, in between these two there will be main scale and vernier scale. Here you can be able to see vernier B and vernier A. If this is vernier A and which is going to read 0 degrees, and at exactly 180 degrees opposite there will be vernier B. So the vernier scale is attached to the upper plate, which is inside the outer spindle. So if the both spindles have a common axis, which is vertical axis, which will be going to pass through exactly center of these both spindles. So next we are going to move to the technical terms which are used in the theodolite surveying. So when you are going to use the theodolite in the surveying, so you are going to use some of the technical terms, and let's see what are those. Vertical axis, you already know the vertical axis, which passes through the exactly center of the instrument and center of the tripod and to the ground. This axis is imaginary axis, is known as vertical axis, and this vertical axis will be exactly perpendicular to the ground surface. So the next one is horizontal axis. This horizontal axis is going to pass through between the center of the A-frame, and it will be truly vertical to the vertical axis, and this will be perpendicular to the vertical axis and parallel to the ground surface. So the next one is line of sight or line of collimation. An imaginary line which is passing through the center of the eyepiece. Here this is eyepiece, if this is eyepiece, and an imaginary line which is passing through exactly center of the eyepiece and exact center of the object glass, and its continuation is known as line of sight or line of collimation. So you are going to use line of collimation term in the dumpy level surveying. So the next one is axis of level tube. So the axis of level tube is nothing but axis of plate level. Here an axis which is passing tangentially to the bubble tube which is placed on the upper plate is known as axis plate bubble tube. Axis of plate level, and which is exactly parallel to the horizontal axis and exactly perpendicular to the vertical axis. So the next one is axis of telescope. Axis of telescope. So axis of telescope, here you can see an axis which is passing through the center of the objective and the eyepiece. It is known as line of collimation, and this can also be called as axis of telescope. So when the telescope is moved, the axis will be moved along with it. So the next term is centering. So you all are familiar with centering term, which is used, and you have done the centering when you are surveying the prismatic compass and also dumpy level. Centering means keeping or placing the instrument exactly above the station using the three tripod legs, and with the help of a plumb bob you are going to center the instrument. The next one is leveling. Using the 3 foot screws with reference to the bubble tube, you are able to level the instrument. While measuring the horizontal angles, you are going to refer plate level, and while measuring the vertical angles, you should refer the altitude bubble, which is placed just beside the vertical circle. Now the next term is transiting. So the word transiting is important. Here transiting is nothing but revolving or rotating or plunging or reversing. So these are all the terms equivalent, and this term refers that the telescope can be revolved in the vertical plane 180 degrees through the horizontal axis. This reversing is known as transiting. So the next one is swinging the telescope. Swinging the telescope means you can be able to swing or rotate the telescope in horizontal nature or horizontal plane through the vertical axis. Just like the dumpy level, you can be able to rotate the telescope in horizontal plane. This is known as swinging the telescope. So now face left observation and face right observations. Here you can observe in this picture, beside the telescope there is a vertical circle. So here the vertical circle is to the left of the telescope and the eyepiece is towards the viewer. Now, so if we are the viewers, then the eyepiece is towards us and the vertical circle is left to the telescope and to the left of us viewers. So if we are going to take the measurements in this position, those readings are called as face left observation readings. Now if you are going to plunge or reverse the telescope 180 degrees and also rotate the telescope 180 degrees in the horizontal plane, then this vertical circle will be to the right side. This vertical circle will come to the right side, and now the eyepiece will be to the other side. It will go to the other side and the object glass will be coming to this side. So that set of observations are called as face right observation, which means you have to move backside this telescope and plunging the telescope and swinging the telescope 180 degrees will make you to observe face right observations. So the next one is telescope normal. So telescope normal, if you are going to read the measurements from keeping the vertical circle to the left, it is known as telescope normal. If you are keeping the vertical circle to the left and reading the observations, then those set of that is called as telescope normal. So if the telescope is inverted, or if the telescope, the vertical circle comes to the right side of the observer, then that set of readings are called as telescope inverted readings. So the next one is changing phase. So the operation of bringing the vertical circle from the left to the right of the observer is called as changing phase. You mean, see here, face left observation means keeping the vertical circle to the left. Face right observation means keeping the vertical circle to the right side of the observer. So this changing operation is known as changing phase. So the next one is temporary adjustment. So you all are familiar with the temporary adjustment. Just like the dump level temporary adjustments, here also in the in the theodolite, you are going to use 3 foot screws. Using those 3 foot screws, you are going to level the theodolite with reference to the plate level for the horizontal measurements, and for the vertical measurements you are going to level the instrument using the 3 foot screws with reference to the altitude bubble which is placed just beside the vertical circle. So this adjustment is known as temporary adjustment. So the next one is permanent adjustment. So here in the permanent adjustment, if the horizontal axis, line of collimation and axis of plate level and the vertical axis are not perpendicular to each other, then the instrument is said to be not in the adjustment. So we have to adjust the instrument so that we can observe the readings accurately. So for the permanent adjustment, we should bring all the axes to which are we should bring all the axes exactly perpendicular to each other, and some of these parallel to each other, like horizontal axis must be parallel to axis of plate level, and horizontal axis must be perpendicular to the vertical axis. Axis of plate level must be perpendicular to the vertical axis. Line of collimation must be perpendicular to the horizontal axis and vertical axis. So the next one is diaphragm. So inside the telescope, just in front of the eyepiece, there will be a ring, copper ring, which will be attached with the hair strings. So those hair strings are called as crosshairs. So the ring which contains crosshairs and placed just in front of the eyepiece inside the telescope, that is setup is known as diaphragm. So the next topic is fundamental lines of a theodolite. So here you can see there are 5 axes. The first one is vertical axis, and the second one is horizontal axis, third is line of collimation and the altitude level axis, and the other one is plate level axis. So here every axis is perpendicular to each other, and line of collimation and altitude level axis are parallel to each other. So horizontal axis is exactly perpendicular to the vertical axis and also to the line of collimation, and the altitude level axis is exactly perpendicular to the vertical axis and also to the horizontal axis. Now the plate level is exactly perpendicular to the vertical axis and also to the other plate level axis. So next is temporary adjustments of a theodolite. Here there are 4 steps. The first one is setting, and the next one is centering, third step is leveling, and the fourth step is focusing. The first step, setting, means setting the instrument to the tripod. So the instrument must be attached to the tripod before placing it on the ground. So after setting the instrument to the tripod, next you are going to place the instrument setup above the station which is required. So to exactly locate the center of the instrument above the exact location which is previously marked, that operation is known as centering operation. So you can do the centering with the help of moving the tripod legs. So the next step is leveling. Using the 3 foot screws, you are going to level the theodolite. So with reference to the bubble tube, keeping the telescope parallel to the 2 foot screws and then moving the or rotating the foot screws either inwards or outwards, you are going to make the bubble to come to the center. And when it arrives to the center, then you should rotate the telescope in horizontal plane and keep it perpendicular to the first 2 foot screws which you have rotated. Then now you should rotate the only remaining foot screw, the single foot screw, either inwards or outwards to make the bubble come to the center. So this operation must be done until the bubble remains at the center whenever you revolve the telescope in any direction. So this completes the first part of theodolite surveying. The next part of the theodolite surveying unit will be taken soon. Goodbye.